Now that we've talked about the random sample assumption in part one, we're going to look at the second assumption that you see in all three of our data collection scenarios. So in the one sample scenario, we're assuming that our data comes from a population with a normal distribution. In our paired samples, we're saying that the differences come from a population with a normal distribution. And in the two independent samples, we're saying that both data sets come from a population with normal distributions. And so as a reminder, this condition has to be true for our confidence intervals to work the way that we want them to. So we need a good way to check to decide, is it reasonable for us to assume this is true, since we'll never fully know what the population itself looks like. All right. So in the past, the way that we've checked this assumption is that we have looked at histograms of our sample. So we've made a histogram, we looked to see if it was sort of close to bell-shaped. And a lot of times that's sort of unsatisfying because what is close to bell-shaped? The histograms, they're a little hard to read in this sense. So we've actually got a new way that we're going to check this assumption going forward, and it's with something that we call a QQ plot. And the QQ part stands for quantile quantile. We are going to get to what a quantile is, but essentially this is just a graph that's going to plot our data against what we should see in a normal distribution. And so I made a little drawing over here, and you can see that our data is on the y-axis, and the normal distribution is on the x-axis. And we're plotting the quantiles of our data against the quantiles of a normal distribution. So what do I mean when I say quantiles? We've seen quartiles show up previously. So in box plots, they were showing the first quartile, median, third quartile, and so on. And in a box plot, the quartiles were dividing our data into quarters. So we had 25% of our data in this section, 25% in this section. And quantiles are basically a quartile that's just a little more generic. So instead of dividing our data into quarters, it'll divide our data into some sort of like equal chunks. So tenths, sixteenths, 37ths, hundredths, whatever you might look at. And so what we're hoping to see is we'll have this sort of 45-degree line. And if our data really did come from a normal distribution, we would expect that it would be sort of spaced out about the same way a normal distribution would be, and the points on this QQ plot would fall sort of roughly along a 45-degree line. SAS actually has been generating these automatically for us. Every time we run a proc t-test, there's going to be a QQ plot or possibly two QQ plots that get generated. And this is really the easiest way to get these. There's some code here to also do this in the univariate procedure. So when you use proc univariate, in the past we've seen that we could have a line that said, say, histogram and then the name of a quantitative variable. We could do the same thing. We could put QQ plot and the name of a quantitative variable, and it would give us a QQ plot along with our output here. So I'll show you that just real quickly. Let me find one of our data sets that we've used in the past. And I'm going to go back a little ways. Let's see, maybe the baby weights data. So we had two groups. We had the non-smokers and the smokers. We were looking at the weights of their babies when they were born. And you can see that I've actually already got some code down here where I generated a histogram of the baby weights. So right under histogram, I'm just going to add QQ plot and weight. And let's run this code here and see what it does. And hopefully, when it pops up, we are going to scroll down and we're going to have some histograms of the baby weights. And we're also going to have some QQ plots of the baby weights. Now, you might notice that there's no line on here like there was on the picture that I drew for you. But if I go back, you'll see that there's some extra code that we can add here. Don't worry about what it's actually saying. But let me just see if I can copy this and paste it on here. And I will just add that. And I'll rerun this, and you'll notice that when I add this normal parentheses and then that stuff inside there, now my QQ plots show up with this 45-degree line. And so I'm hoping that these dots will fall sort of roughly along that line. It doesn't actually really look like they do. All of these ones are below the line. They're also below the line here. And so maybe this isn't going to be the best. I can also real quick show you what it looks like with proc t-test. So data equals and see smoke. And since I really just want the graphs, I'm not going to add H0 or alpha or anything like that. But I do want SAS to know that I'm looking at a 2-independent samples problem, which is why I've got class and var here, just like I had in proc univariate. And I will run this proc t-test code real quick. And I'm going to scroll down. Here's my histograms. You can see some box plots also. And here's those QQ plots that are being automatically generated. And again, you can see they don't really follow this 45-degree line. This one's got sort of this curve here. And in the activity that you're going to do in just a second, you'll be able to figure out, okay, what kind of distribution does this match up with? So if I go back to the notes real quick one more time, there's an activity that I want you to take some time to do. And you're going to look at 4 different mystery files. So they're just 100 observations from some sort of population. Each population is either a normal distribution, a t-distribution, a right-skewed distribution, or a left-skewed distribution. And you're just going to describe what the histogram looks like when you look at it. So does it look bell-shaped, right-skewed, left-skewed? Make a little sketch of the QQ plot, so look at what you see, and then take a guess at what the distribution is, and I'll have solutions posted that give you the actual answers for those.